Welcome to part 2 in the continuing saga of the Arch Transmissions transfer case from the Wingit 445 dumper. A rainy day has occurred, so I've had a chance to strip the transfer case down and take a better look at what's going on inside. The main reasons why this box had been taken apart was external oil leakage, and the parking brake disc, which fits on the input shaft, was awfully loose. As you can see it there, wobbling around. Quite obviously, all of the 3 oil seals on this case will require replacement. That's nothing major. And having stripped and cleaned out the case, one of the first things that's noticeable is that the chain has been so slack it's been wearing against the sides of the case and put these grooves in. Luckily it's not gone all the way through. Upon examining the chain, you can see that somebody's put a half link in. This is a bodge because the original literature does not show a half link, and if you look at any design guide on roller chain drives, it tells you that half link should not be used on heavily loaded, high speed or impulsive drives. And on a dumper you have all of these things. The output shaft of this gearbox can run as fast as engine speed in top gear, which is 2000 RPM. Unsurprisingly, the roller bush that is next to the crank link is missing, as is that one there, and that one there, and that's missing even more bits. I found the bushes in the bottom of the case. Hilariously, some of these had passed through the ball bearing races and got onto the other side of the race and were against the oil seal. Wow. If you look along the chain and look at the rivet patterns, you can see that somebody at some point in the past has had this apart, and looks like they've added some links out of another bit of chain, or just special. The bearings are obviously also knacked, but because they're marked as a Japanese make, and I can't believe that a box of this age would have included Japanese bearings, that together with the half link is our indication that this box has been opened once before in its life at least, and had at least some attention. Perhaps not all of that attention was very helpful, hey? Luckily, all of the bearings are a common metric size. They are 30mm bore by 72mm OD, so there's going to be no difficulty replacing those. Sprockets. This transfer case has a 13 tooth driving to a 19 tooth. They are 1-inch pitch simplex roller chains. You can see some interesting damage along here where the detached bushes have been mangled in between the chain and the sprocket teeth. Same on the other one, and you can see the teeth are badly hooked. Interestingly, on one side the sprockets have these burrs, and if you flip them over, the wear pattern is entirely different. Possibly there's a reason for that. The sprockets are made by having bought a plate sprocket and welded it to these splined bosses, which is certainly an interesting way of doing it. They do run pretty true on the shaft, I've tried, but most people would tell you that certainly this 13 tooth driver would need to be hardened, and having a weld that close to the sprocket teeth where hardening would have been done is surely going to compromise the hardening. So that's not sure what to make of that, really. Nothing much to see on the cover of the transfer case. Interestingly, the cover is flame cut from steel plate, whereas the case body is an iron casting. I would presume this means that they are a matched assembly and you can't replace one without replacing both. Here in this blanking cap, this is the other end to the input shaft at the top. I found numerous bits of mangled chain bush. The only way they could have got there is to have passed through the bearing, which funnily enough had a really mangled cage. The two output couplings for this box I think are going to be salvageable. The oil seal face along here isn't too badly scored, and I think that'll polish up okay in the lathe and is capable of further use. The fit of them on the output shaft, there's a little bit of slack on there, but nothing that I'm going to get really upset over. Probably going to want some Loctite on the nuts that hold it on to stop things coming loose, but I think that's probably going to be good to go. Sadly, the same cannot be said of the input shaft. When I took off the small sprocket on the input gear, you can see there's a big burr along there, where insertion of the shaft into the sprocket has caused a huge, nasty kind of tidal wave of metal to be displaced, and as a consequence this sprocket was not fully assembled onto the input shaft, which has had a knock-on effect. That knock-on effect is that the brake disc, which is also the input drive coupling, was not fully home on the input shaft, and the splines did not have full engagement. The gap here should be set by the thickness of the bearing, but because the sprocket wasn't on fully that end, it meant it was pushing away this end, which meant that the drive coupling was not fully on. This can be seen and demonstrated if we push that on as far as it should go. There's not a too terrible amount of backlash, but as soon as I pull the shaft away, you can see that there's suddenly a lot more backlash. The wear can be seen along the shaft, and that's the position where you can see the drive coupling ended its contact, and we go back onto an unworn part of the shaft, and there it is again. That angle there is represented by the chamfer, the introductory chamfer on these spline teeth. By measuring on an unworn portion of the spline, we have 313 thou, or maybe 5/16 of an inch, or 8mm. But go a little bit back and we're down to 286. So, gosh, that's quite a lot, isn't it? That's like 3/4 of a mil of wear on there, which is clearly no good at all. The brake disc that mounts on here is never ever going to run true or reliably anything with that amount of wear. On the other end of the input shaft, where a bearing race was pressed, is this Hall of Fame example of, I'm not sure what's gone on here. It would be easy to say somebody has brutalised this component, but there is that evidence of scoring around there, and I'm wondering if maybe a bearing has previously spun on this shaft and somebody's managed to get it off and grind the shaft back to separate the bits of failed bearing from the shaft. What a mess. But they did a good job, because if you measure around here, it comes out very accurately at 30mm as an average measurement all the way around. At this point we've got a knackered chain, two knackered sprockets, a knackered brake disc integral with the drive hub, and a knackered input shaft, which would, if you could get the bits, add up to an awful lot of money. And this transfer case is utterly obsolete from a manufacturer that no longer makes them. So the next obvious question was, stuff it, let's just throw this obsolete piece of tat in the bin and find something that maybe secondhand or at least you can get parts for. A quick scout of the website of a leading transmission manufacturer, Newage Transmissions, shows a range of transfer cases just like this, suitable for off-highway applications. However, there's a problem. They don't really offer anything with a centre distance this great. Well, that's kind of weird. Can we reconfigure this to get away with a smaller centre-to-centre difference? And the answer is no. So what's so special about this dumper that it needs a transfer case with such a vast difference between the shaft centres? And the reason is because it's an early generation of four-wheel drive dumpers. On a modern four-wheel drive dumper, the pivot chassis does the steering, but also your suspension. This dumper is not like that. It does steering only, and underneath the rear chassis section is a floating rear axle. That floating rear axle adds height to the machine. It puts the engine higher up, which means that there is a greater drop required on the transfer box to get the driveline down to the height of the differentials which drive the axles. Modern dumpers, you have both the steering and the chassis twist all in one, which allows your transfer case to have a much smaller centre-to-centre distance. So the chances of finding another one like this that's not the same make and also obsolete is slim enough that avenue of inquiry has been dropped. Going back to the earlier observation with the unusual pattern of wear on the sprockets, we've got this loss of metal on one side and on the other side a build-up of metal with these big burrs. I believe that the cause is incorrect assembly of this shaft, where the sprocket, because it didn't go fully on there, has been running off to one side, which has been making the chain have to do a zigzag to reach the sprocket on the other side that's not quite in line with it. This brake disc is probably the easiest thing for me to deal with. It's unobtainable and the spline in the middle is knacked, but the disc itself isn't especially worn. I think this will clean up with a bit of work. And the easy fix on this is simply to machine off this hub entirely, get rid of it, keep a little register on the back, and then with some appropriately sized steel bar, machine a new hub that will just through bolt into these existing bolt holes, fit in there with a spline cut in the middle. That's pretty easy and straightforward. I'm still awaiting information from Wingit to see if they can supply this shaft, which is possibly one of the more problematic items. If they can't supply this shaft, I'm considering using a carbide end mill to mill down the one side of where the wear is. The wear is only on one side, which will turn this into a non-standard spline, but will recover the shaft. I've got to make the mating part anyway. I've just got to cut wider slots in there, but just looking at the state of it, I would rather buy a new shaft. So that's that problem potentially solved one way or another. The sprockets, I can't get my head round. This small 13-tooth sprocket really needs to be hardened, and I'm struggling to see how you could call it hardened when it's also had that weld on there as well. When testing with a file on the teeth, it can be filed, but it seems slightly harder than mild steel or maybe even EN8. But the action of the chain racing over these sprocket teeth under load has quite possibly work hardened this anyway. Some more thinking is going to be required on that. This shape of spline in the sprocket centres is like a Gothic arch shape. and not as easy for me to cut in the workshop as a straight splice-sided spline would be. Part of me is thinking of machining out these bosses and reusing them. They are, after all, a good fit on the shafts. Part of me is thinking that welding this together is an incredibly bad idea and I should be trying to do something better. The state of these teeth is amusing, if anything. In power transmission products, this would be classified as a Type C sprocket because there is a boss on each side. Sprockets are generally available as just either a flat plate sprocket or with a boss on one side. This is clearly been bought as a simple flat plate sprocket with no boss on and welded onto this boss, which has been splined out somewhere else separately. Type C sprockets are pretty difficult to get as off-the-shelf items, but it's occurred to me that I could buy a duplex, that is to say 2 chain wheels, Type B sprocket, which would get me a sprocket with a boss on one side, and then I can machine off the unwanted sprocket teeth in order to get me the boss on both sides, which I could then try and cut a spline in. But that doesn't seem the best solution, but neither does welding a lump in the middle either. So there's still some more chin scratching to do there. The completely knackered and bodged chain is of course an easy item to replace. That's 1-inch pitch simplex roller chain that's kind of £20 a metre. So that's dead easy to deal with. I have checked both of the shafts for trueness in the lathe and they are pretty good and not bent. If you take it that the transfer case is a matched pair of the cover with the body and it's nearly knackered, the chains are knackered, the sprockets are knackered, the input shaft is knackered, the brake disc and input coupling is knackered, that leaves this component as about the only good part of this box. As for a video, this sorry collection of parts kind of represents the end. Next time I make a video on this box, it will either be because this one's gone in the bin and I've found a better alternative, or it'll be because I've reached a decision on the way forward. Things really to be decided is how to get round a new set of sprockets. Do I go for welding and possibly compromising any hardness, or do I buy some duplex sprockets and machine them down to at least keep it all in one? But then I've cut this spline, which is troublesome. It's not even an even number of splines, it's an odd number just to make it complete arse. And of course this little beauty here, the input shaft. Until next time.